All right, take three. Welcome to the Awkward Performance YouTube channel. My name is John. Welcome back. Going to give you an update video. I didn't forget the microphone this time, and I didn't pause and screw up talking too much. I'm trying to do this all in one take. Editing is no good, and I'm garbage at it. So here we go. I am on to the second operation, or Op 20, in the industry. When you machine your first operation, it's Op 10. Second is an Op 20. It's new to me, but I'm using the words. Op 10 is machined or programmed. It's not machined yet. It's programmed. Done programming it. Have all the tools for that operation. Very excited. Operation 2. I'm beginning on the hundreds of tool path. The Op 10 took about 400. And that's a lot. But this is a complicated part. I am still battling Fusion 360, but coming up on the successful end, just not on this particular tool path here, for example, where I want this to machine down to that depth. And I have all the same specs to this job, and it won't go past the mouth of the port. But I'll get that. I'll leave this showing the cut stock because, as in the first operation, we got the exhaust ports all the way cut. The intakes are going to be all the way cut as well. And so when I could approach the cylinder head this way with long skinny cutters, I came in and got the short turn radius machined up to a point to where I could hand off to the second operation and get it from this side. So this tool that's being modeled right now for this roughing, that's about a $1,500 setup with the holder included. I hope it doesn't chatter. That's all solid carbide with a replaceable tip. Pretty fancy stuff. Just to give you an example of what I'm having to do when I post that I'm buying tools, this is kind of what I'm up against, is thousands of dollars. But it's all worth it because I can use them at my shop if I wind up not making them on 5-axis machines with my redneck trunnion table. They all work the same. They don't care about what machine. So this will get finish ported. Right now, this is the roughing, which you could probably finish by hand. But why, when you can do it on the machine, get it done? So you can see that I can reach the short turn radius right at the curve of the valve seat, which is nice. So there's much programming to do still. There's a lot of water holes, O-rings, all kinds of good stuff. There's things I couldn't hit in the first operation, like this hole right here. That completes the water jackets, as well as these on each side. I'm putting that in the video so I don't forget to program them. It's really easy to forget. So, making good progress. There's an update on how I'm going to be fixturing these. I'm using and it's basically Lang work holding knockoff stuff available on Amazon. But there's these fixturing systems called 0-point fixturing systems. And they have a screw on, for example, each of these highlighted faces that I'm showing. And you undo that, and you can design this custom fixture, or whatever fixture you want, install the pattern of the pull studs in there, and clunk them down into the 0-point plates, tighten and torque them, and have within, like, they say 0.2, but let's say 0.5 thousandths of accuracy of, repeatability. That's pretty good. It's good enough for these. So I've spaced them unevenly so that if I'm working overtired, I can't put it in the wrong way. If you ever build fixturing for yourself, if you're a do-it-yourselfer, not a bad idea there. We're so used to making symmetrical patterns, sometimes making stuff go only one way, especially if you're handing the job off to someone else. It makes a big difference, reduces errors. So that's kind of my update with the Op 20. We got a whole pile of jobs coming along, and that's about where we're at. I hope to be programming the finishing passes here once I figure out how to get the adaptive to do its job on this again. I don't know what I did the last time. I just kept redoing the jobs and divorcing the connectivity from one job to another. I would, if you're out there and you know, please put in the comments what is going on, because it is bizarre to me. So, in other news, let me look at my list here. LT1 Gen 5 test fit. I got one of the engines in. I got a 5.3 aluminum block, direct injected deal, and plan on getting a 3D scan of the block, but took my 3D prints and head gasket, and we did a test fit with the heads. Lifters are in the same spot. These will work on an LT1 with a couple of exceptions. You've got to get an LS lobe orientation cam, and you got to put flat top pistons in, because the LT pistons have some terrain on them, some dome, and that splash for the direct injector that winds up interfering with some of my squish pads. So if you plan on using an LT block, no problem. The coolant ports I made wide here, got lucky. That lines up with the slightly moved steam holes. They'll work. If you order them, I'll go and make sure to put the dowel pin up at that location, and you should be good to go. I don't know what you'll do for injection. I think it would be kind of funny to take the direct injectors and build a manifold for them and spray the fuel back into the port. I don't know if that's even possible or if that would screw the injectors up, but that's a good news deal. I don't have to do much other than the dowel pin to make them work on the Gen 5 direct injected LT stuff. And they'll fit down to the 5.3, 3.78 bore. So that's a good news. Don't know yet on 351 Cleveland or Windsor or 504. They should. Still to be determined. As I get those engines in, I will be check fitting and see what we got to do for camshaft and water modifications. But I'd sure like for these to fit on the small block Ford Pro platform. There's no reason why they can't. Just got to have the stuff in hand to go make those adjustments. So that's about where we're at with programming in Fusion. So got some couple of exciting things here. The program I use for my day job is Hypermill, and let me see if I can get a good example queued up. Nope. I'm not technically good enough to do that. Hang out one sec. So if I can stop double clicking everything. There we go. So this is Hypermill and Virtual Machine. So you'll see here that this machine can cut rapidly in simultaneous 5-axis. That there's the cam system to generate the toolpath, and then you check that you're not crashing the machine and wrecking your part in the virtual simulator. So similar to Fusion 360, much more fancy and much higher performance machining. So given that, there's been an interest of mine to be able to program the Hermleys with my Fusion 360 system. And there's a bunch of people out in the world that are doing that and getting pretty good results. So there's a cylinder head that I have welded up due to some corrosion damage, and I did a 3D scan of that cylinder head. Took the chamber over here and put it over the damaged one, and then slowly recreated the surfaces in Fusion 360 off the 3D scan data as close as possible to kind of move the tool path away from the spark plug hole, because I don't need to cut that. I can always hand put that in. But this is kind of a gnarly situation because I've done my own 3D scan, put that data in, verified that it was correct, aligned it to a proper small block Chevrolet bolt pattern and bore spacing as best as I can. And you can't really align this stuff better than kind of by eye, but you can zoom in far, and I hope you can maybe see that I'm using the use of very accurate Sharpies to get spark plug angle inclination as well as head bolt pattern to align it to the stock small block pattern. So you can have a perfect drafting, and you kind of move your 3D print in and line it up as best as possible. What's nice is it kind of correlates with a lot of the other geometry there, and you can pick up other scan data. And so the red cylinder head that you see is the rest of a high quality scan that's also been aligned. So I'm using more than one point of data to get these things aligned to do the cylinder head repair. So that's a bit of futzing around. And then finally got the gumption up to go and load this into the C650 at work, seeing that they have the TNC 640 and TNC 7 post-processor in Fusion, and went down the road of machining it, and that was honestly kind of terrifying. So after accomplishing that, I feel a lot better because I can repair cylinder heads if they get hurt very quickly with all of my own in-house tech between the 3D scanner, my own software. I'm not dependent on someone else's stuff. So that's very nice. I hope the video comes through of a screen record of the video of it cutting. But that was hard to film with your hand shaking. But that's an accomplishment nevertheless. Next thing. Got, Dodge Viper stuff. So earlier this year, picked up a Dodge Viper motor. I think it's actually out of an SRT10 truck, but they're the same. It's not the same as what came in the 2500 Rams for towing. That, I believe, is still based off the LA engine. This has got a completely different bore spacing and kind of bizarre. They like added 14 millimeters to 4 inches. It's like 451 bore spacing. So looking at those blocks, they're very, very similar to, and the heads are very similar to LS heads. And I can utilize about 90% of the technology of valve springs, seats, rocker geometry, etc., and transfer it over to do a 5-cylinder head and make 2 of them to go onto a Dodge Viper. Seems like guys are drag racing these things and doing the half-mile challenges, and there's no real aftermarket cylinder heads for them. So while I wait for tools and recover from exhausting programming, it's always nice to keep working on the next thing. I have so many irons in the fire, and I kind of cycle through them to keep from burning out on any one particular project. Nevertheless, working 50, 60, 70 hours a week. So the other day, I finally got the Viper block up in the Hermley to go do some probing. Let's see here. Where is that? There we go. So I needed the tappet locations, most importantly, so that I can go get the push rods running up into the head and know that they're not going to hit. It's not exactly the same as the LS. The pickup, the heights of the lifter cups are different, but it looks like a head is going to be possible to make with this 4-valve technology as a bolt-on cylinder head for the Dodge Viper. While I had it in the machine, I went and probed just about everything else in it and got it to where I have enough data to go make a billet block. I don't want to go make a billet block, but having the model to go make a billet block is very important to me. If I can hand that model to someone, if they want it to go make a billet block, that would be really, really cool. So definitely staying busy in the meantime. Okay. Made some valve cover spacers for my Corvette engine. What else do I have here? I guess we'll go back to the list. So that's about it. So waiting to buy tooling. It'd be nice to get, I don't know if I showed that on the screen yet. Maybe I'm being redundant. But I need to go and order a fancy ball and mill like this, because the C650 is a huge machine. It's got less angular availability on that trunnion table. So you got to go to an undercut or a lollipop cutter for the porting. So if I order that and that, the minimum order's about $2,400. This does all the O-rings deep down, so you don't have to put that into the thin plates to block off the water passages. But that should be the last tooling order I need to do for a while. So next month, it's going to be a skinny month. So some of the other projects I've been working on and started on years ago, seeing that I like to reverse engineer engine stuff and develop better solutions. One of the projects I did, and we're waiting to fire these heads up, is my buddy's deep into the Corvair game. He's on Instagram at Billet Corvair Heads. Billet Corvair Head? Let me look that up really quick. That way I can be accurate. Billet _ Corvair _ heads _. So check those out. Those were the first complete cylinder head I've ever made. And it's an air-cooled deal. Flat 6. We canted the valves, modernized the combustion chamber, did all kinds of cool stuff to go and make them run. Check him out. Hopefully later this year, he'll be running those things on the dyno. And looking forward to see how they do. Air-cooled world is a bizarre place, but should be able to make a pretty powerful little engine. And that's still a 2-valve. Trying to talk him into doing a 4-valve. And then the other project that I get asked a lot, mainly on my Instagram, is I started off doing a K-Series V8. Right, the Honda K-Series engine's fantastic engine. Cylinder head's pretty killer, even right out the junkyard. So the LS heads took precedence. I started on both of those projects right about the same time. I have most of the work worked out on getting that to work. I'm been in contact on and off with Neutron Engines, who's doing the Hot V setup, more of a Formula One style engine. He's doing a fantastic job at that thing, and he's not updating it as much, but it seems like he's still moving forward with his, and I look forward to him completing it. I will be getting back to mine once all of this billet head nonsense gets up and going. I still have 100% intend to make a block kit for people to go take their K series heads and bolt them on. I'm kind of doing a jack shaft, like a 4.0 V6 Ford. Ugh, makes me shudder to say that, but I have a big block Chevy timing chain and all the chain pathing routed to where we can run proper chain tensioners and run the heads as a traditional intake on the top, exhaust out the bottom system. You'll have to order custom pistons. The pistons for my system kind of works out that a 4.6 liter Ford modular engine has it's exactly 100 millimeter bore spacing, but it's narrow enough to shrink it down to the K series 94 millimeter bore spacing. And if you put the rods offset in the pistons, the rods and pistons don't care. So with that, you can run the 5.4 or the 4.6 or the SCAT 3 3/4 inch stroke crankshafts. Ideally, someone should find some flat plane crank because everyone likes that stuff. I don't. They shake too bad, but that gives you some crankshaft options off of known bearing technology, known strong crankshafts. And if I could make a block bolt together like a motorcycle engine that accepts K-series heads, the world's your oyster on what you want to do with it from there. So that still gets me excited. I still think that'd be a wild street engine to go run around with. You should be able to, on E85 and some turbos, be able to clear, 1,1300 horsepower and have a very high revving V8. It's just kind of a neat project. So sharing some of the other stuff that I'm working on. Again, LS heads take precedence. I'm not spending a dime on anything else really until those heads get up and going. It's a huge effort. I hope it's appreciated. Regardless, it's worth it to do it. These exercises for me are very fun. Wild horses couldn't pull me away, but I'm looking forward to getting these suckers on the dyno and fired up. If you got any questions, please leave them in the comment section. Love to hear back. I'm doing everything I can to get these going this year, and we're stepping closer. If I can do them on the Haas, I'm going to do them on the Haas. If I can do them on the Hermle, I'll do them on the Hermle. If I have to go do it at my shop, I plan on at least doing one here just to say I did it. I'm building a kind of my redneck trunnion table system, and I plan to do a couple of videos on that as well. I finally got my shop back in order. We had to clear out some deadwood CNC machines and then power the machines back up. I've got my office back in some semblance of order, and looking forward to being more active on YouTube. Thanks for watching. Check you later. Definitely forgot, end of the video time, bonus material. The third take, I forgot to go over the rocker arms. So this is using Fusion 360, or I guess it's just called Fusion now. Their simulation software, finite element analysis software. I'm sure there's other names for it. This is the exhaust rocker. This has been the biggest point of my concern through the whole cylinder head. So the thing that's going to get worked the hardest is this particular component. Some guys at work were kind enough to help me understand how to utilize the software, and things are actually looking really good. I started with my previous revision. It was way overkill strong. It had a lot of unstressed components on it. And that means they're not doing anything, right? And so that's extra weight on the rocker arm that's going to hurt RPM, or you're adding force to the system to compensate for material that's not helping you. So I revised the design and more or less isolated the weak arm. So the weak arm is obviously the one furthest away from the push rod. The max deflection with it out of 70-75 or 70-50 material, didn't seem to change much, is about 2.5 thousandths of an inch. So this color gradient, as this is set up right now, is under displacement. So this is how far it will flex outside of its normal final resting state. The strain and stress on it both also came out very, very similar to one another. So I don't have any anomalous, hey, you have stress over here, but strain over here or over there. Everything seems to match up quite nicely. And initially, having this rocker arm, or this the further finger on the rocker, not have as much torsional load compared to the one that's close to the push rod, you would think is a disadvantage, but it actually plays to our advantage here. So I'll explain quickly that this rocker arm is going to be on a shaft rockers. The adjuster is on the push rod side, and I'm running roller bearings on that ground shaft. So the shaft goes into the counter bore, kind of where you can see where it says minimum 0. That's where the bearings are. So you define this with a plug, as a frictionless plug that fills that area right there, as well as the other side, because it's going to be, all the force is going to be between the bearings. And the nice thing about this, if you run boost, especially when your exhaust valves open into cylinder pressure, if you have two 1.3 inch valves and you're opening them simultaneously into, say, 500 to 1000 psi chamber, it's quite a bit of force on the rocker arm, push rod, valves. Even the camshaft is not going to be happy with it. So this will bias to open only one of those smaller valves, smaller than your stock LS, smaller than your big block 1.8 diameter valve, down to 1.3. And you have squared area working for you here. So this should, if you set your valve lash appropriately, tight on the close one to the push rod, it will crack that tiny valve into the cylinder pressure, dramatically reducing the amount of force that the cam, lifter, push rod, and rocker assembly have to see. And once you crack that pressure off and it begins to flow out the exhaust, 2.5 thousandths or 3 thousandths behind, if the other rocker can only deal with, or not the other rocker, but the other finger on the rocker can only deal with opening the valve spring itself, this becomes a very, very livable system. The material cycles out at about 1.7 million cycles. So it's got a lot of life in it. Again, these heads are not your 300,000 Toyota Camry you're going to drive every day. If you do, it'll probably exceed that, because I'm looking at engines that are running extreme high boost and drag race trim. So the safety factor came out to about 4.5. And that's pretty good. That'll run. I'm confident that this will not break. Like any testing, it's always nice to go, well, let's double the forces on everything. So this was initially tested with 400 pounds on the roller pins. I have them hidden so you can see more of the data of the rocker, as opposed to the pins that are going to be transferring the load from the lash caps and the rollers and the pins. We're not worried about that. I'm worried about my aluminum part. So they were set at 400. I tested them at 800 and 800 each. And the 1,000 pounds that I initially had on the push rod, I doubled that to 2,000 pounds. And the displacement number went up to about 7 thousandths. Still more than acceptable. Safety factors down to about 2.5 at that point. But hopefully your valve train won't be experiencing that much force. If it does, this will still more than happily handle it. What you will see if it doesn't is your valve lash is going to open up, right? Because it's going to smash that rocker up. And I hope that rocker actually acts as a fuse. Roller lifters, push rods are not cheap these days. Camshafts are especially not cheap. And so if this becomes the fuse and the canary in the coal mine, if your lash starts moving, you can probably bet that it's the rocker, and you probably have some kind of tune-up problem. So there you go. That's the other cool part. Thank you for the people that helped me with this. Much appreciated. If you are designing stuff and want to analyze it, I recommend using Fusion 360s as a preliminary deal. ANSYS is very expensive. I can't afford it, but this works pretty good. And I think it uses some of the same engines that ANSYS does. And the resolution on this was more than good enough for a project like this. So, all right, I'm going to stop rambling and yapping. Y'all have a good one.